On today's episode, we've got the latest updates on this year's AI Day, how the Tesla bot Optimus will see the world, the Dojo supercomputer's amazing performance stats, and full self-driving's simulation tests. There's a lot to get into this week, so let's get going. Tesla's AI Day 2022 kicked off last Friday, and just like with the previous years, we have a flood of new tech to sift through, and first up was the long-awaited showcase of the Tesla bot nicknamed Optimus. Wasting no time, CEO Elon Musk and his engineering team brought out a fully self-supporting and walking human-shaped robot. Elon delivered the goods. He gave us a robot. But what we didn't see was an actual Tesla bot. We just saw a bot made by Tesla. Now, what does that mean? This is the first prototype nicknamed Bumble C. That's another Transformers reference. And this is what Tesla was able to cobble together in less than 6 months using off-the-shelf robot parts. As far as robots go, it's nothing special. They said that this was the first time Bumble C had ever walked without a support tether, and it did an okay job. Then they literally dragged a more advanced prototype that was much more in line with the Tesla bot design. More sleek and streamlined, less wires and stuff poking out. This new guy looked very cool, but he wasn't able to do much, just kind of stood there. Elon says that this prototype is pretty close to what the production Tesla bot will look like. After that, things got very technical on the robotics side of things. They showcased movement, internal specifications, and the complexities of the Tesla bot's hand actuators. But the standout of the whole Optimus presentation was the section where the team showed off how Optimus sees and navigates the world. Elon and his crew briefly reminded the audience of what they wanted Optimus to do: repetitive or dangerous tasks in and around human-occupied spaces. For that, the Tesla bot would need a navigation system that would rely on the same spatial cues as we do, and luckily, they already had a software for that. Of course, the Tesla bot is going to be using the same system as Tesla uses for their cars, Pure Vision Autopilot. Instead of LiDAR and radar, like other contemporary robots, the Tesla bot has 3 cameras that give it a full view of its surroundings. There is 1 central fisheye lens and 2 side view cameras. It seems to have a field of view that is a bit wider than 180 degrees. And Tesla's computer vision gives the bot shape recognition and edge detection so it can navigate and interact with objects in a 3D space. And from the videos they showed, it's actually working pretty well. We got a very brief look at how the robot can see the world. In the first clip from the beginning of the show, we can see how the bot identifies and color codes the objects that it recognizes. The watering can is blue, the plant is red, and the people are green. The obstacles like the desk, the planter, and the walls are plain white. The floor is purple. Stuff like that to show that the robot is aware of its surroundings and knows what it is looking at. At a later point, they show video of the bot's camera inputs above a rendering of the 3D vector space that the computer uses to perceive the world. So, just like with the cars, the camera video is instantly converted to a 3-dimensional digital space with a bird's eye view perspective. Again, we can see here that the bot is identifying people with green pixels and obstacles in white. We can see how the bot perceives depth, showing objects that are close as a darker color and things that are further away are a lighter shade. And they show us the bot's navigation layer, using edge detection to create a map of the room and identify a clear path through. The other major point that could have been lost in all the dazzling technical displays is their ideas about construction and scaling production of the Tesla bot. The original concept and first design platform used semi-off-the-shelf components. Elon's idea for this robot is that it's supposed to be a domestic helper, and so making it too expensive to produce just wouldn't work out. This isn't some technical display like a Boston Dynamics or Honda robot. Optimus is meant to be mass-produced, and Just like how Tesla was the first company to mass produce electric cars, they want to be the first mass market droid producer as well. The techs walked us through the iterative design process. They went from idea to first prototype in 6 months, then to the second prototype in 6 months after that, designing for cost and manufacturing efficiency. Again, just like Tesla's cars. And this is really the sticking point because it defines the whole Optimus showcase. The Tesla engineers needed to design a working robot with emphasis on affordability and usability, and they had to do it before any other company, many of which had several years worth of a head start. So they looked at their cars, realized that they were already building these robots, and found a way to put them on 2 legs instead of 4 wheels. Genius. That sort of thinking has given Tesla a humanoid robot that can walk under its own power and identify its surroundings properly in a little over a year. So, how long until it's doing your dishes? Tesla's Dojo supercomputer has been in development since before last year's AI Day, and now we are getting a better sense of how it will stack up against Tesla's existing GPU compute rigs. When unveiled last year, Tesla's Dojo project was explained as an AI training tool. Basically, the computer would run simulations based on real-world data and use those to train the AI software that would let Tesla vehicles truly self-drive. For this task, Tesla is still using huge GPU farms, racks and racks of NVIDIA graphics cards, all struggling to process the data and train the AI. But NVIDIA GPUs aren't really built for this specific work. The GPUs are designed for use in a variety of situations, and so there are bottlenecks that slow down AI training. For starters, communication slows everything down. The cards need to talk to their own memory. They need to then pass data between the cards in the same rack. Then they need to talk between the racks. There's a lot of data traffic, and while the current tech has been working, it's working too slowly. Currently, Tesla says that training for any specific driving scenario takes about a month. Waiting that long for results that might have to be adjusted and tested again is just too long. And so, Tesla engineers started designing a purpose-built supercomputer with 2 goals in mind: density and scalability. First of all, they made the individual tiles, the chips that do the processing, to fit together differently. As Tesla explained it, part of the reason other chips have a bottleneck is because power and data transfer happen in the same direction. With the new configurations, Dojo chips pass data communication laterally across the wafer they sit in, while moving power and heat vertically. There's a lot of extremely technical things happening with the integration and construction of the Dojo trays themselves, but this density mindset is mirrored in every step of the process. By the time 6 of the training tiles are connected together into one tray, it has enough compute power to fully replace 4 NVIDIA A100 GPU racks. And then they put 2 of these trays into one Dojo cabinet. At that rate, Dojo takes that 1-month training time for the GPU system and reduces it to less than a week. Operations that take the normal rack of 24 GPUs about 150 microseconds, one single Dojo tile can complete in just 5 microseconds. Benchmark tests show the Dojo chips surpassing the NVIDIA A100 by over 4 times when parsing real-world data, which is incredible. And it just keeps scaling. Tesla engineers are working on a system for cross-cabinet data communication, so once a single cabinet full of Dojo racks are put into a unit of 10 other cabinets, they can all talk to each other with as little bottleneck as possible. Tesla is calling this configuration the exapod because it produces 1 exaflop of compute power. A flop is floating point operation, basically a single calculation performed by a computer. To put an exaflop into context, imagine a billion people each holding a billion calculators, all pressing the equal button at once. It's a little bit of an oversimplification, but it should give you all an idea as to what just one of these Dojo groups can handle. Tesla's plan is to build the first full exapod by next year, which would replace the current 72 GPU server cabinets they use right now, and more than double their training capacity at the same time. And they plan to build 7 of these exapods at their Palo Alto facility in California. This work is probably the most impressive, but also most technical presentation at AI Day. The Dojo project will supercharge all of Tesla's other AI work, and it seems like it can only get more and more powerful. Tesla took the opportunity to show off some new techniques for training their full self-driving software in addition to their other big AI projects. With all the talk of AI cross-use in the other presentations, it was safe to assume something new was cooking for Tesla's FSD, and we were not disappointed. Tesla engineers were extremely excited to show off a new method of simulating real-world environments for their AI to learn from, and it is extremely impressive. Tesla's FSD operates on a mostly visual system. 8 cameras take in everything around the vehicle, and the AI decides what to do from that input. But if that's all it took to be a perfect driver, humans wouldn't get into so many accidents. Like any other new driver, FSD needs to practice. Tesla currently uses GPU server farms to build out environments to train their FSD intelligence. Out of the 14,000 GPUs Tesla has, it takes 10,000 to train the system and 4,000 to auto-label, an AI system Tesla uses to pick out cars, pedestrians, and other objects from the background. On top of that, it takes over 160 billion frames of video to train an AI system for a specific stretch of road. Now, obviously, they don't train these systems on a real road, as mistakes there have consequences. So Tesla have previously used video mapping software with the help of artists to build out simulated versions of roadways to test the FSD software on. It generally takes an artist around 2 weeks to build out a single scene, just one intersection or stretch of road with all its obstacles. But with new software tools, Tesla can now generate most of San Francisco in 1 week with only one person directing the tools. And better yet, all of the data they build these models with comes from real-world data, so it will include all the little quirks that real drivers have to deal with. Now, obviously, this will take way more computing power than Tesla currently has, but with the first Dojo cabinet being constructed, you can see how one breakthrough leads to another and another. Engineers build a dense computing chipset, which helps make Dojo a reality, which lets FSD learn much faster in a digital simulation, which finally ends up informing the logic and navigation software of Optimus. Everything Tesla's AI team does fits together like a puzzle, and it's all snowballing right in front of our eyes. Don't forget to give this video a thumbs up today if you liked it. That is so important for getting our content out to more people. If you enjoy the content, then you'd probably also enjoy our weekly newsletter, so sign up with the link down below at theteslaspace.com. A huge thank you to all of our Patreon supporters who are listed on the screen now. You help us make the best content we can, and we really appreciate it. Thanks for watching, and we'll see you in the next one.